Hello and welcome. In today's video, I'm going to show you how to persist your data in the database using TypeORM and NestJs framework. I will show you how to create a table, query your data, and create relations between tables. Please watch this video closely and to the end, cause TypeORM has a lot of easy to fall traps. It may save your time instead of spending it on debugging. Also, you can find link to the source code in the description of the video. Okay, enough talking, let's get started. To make things simple, I do not require you to install any database. I've just prepared the Docker Compose file. You have to have Docker and Docker Compose installed on your local machine to make it up and running. If you don't have, I added a link to the Docker installation manual. Don't worry, if you don't have any knowledge about Docker, it's not essential to finish this lesson. The Docker Compose file is written in the syntax following the version 3.4. There are two services set, Postgres and the adminer. The adminer is a web tool for accessing the database data. It supports the most popular databases like Postgres or MySQL. The PostgreSDB is one of my first choices when we speak about relational databases, so I decided to pick it as our persistent store. When you look closely to the Docker Compose file, you may notice that there are some environment variables set. Here, we have the credentials for the PostgreSDB. Next, I opened the ports so we can access the DB from our local machine. Then, for the adminer, I did the same. I also opened the port so we can use it. To start the database and the adminer app, please type command docker compose app. This command will fire up those two services. The adminer app will be available on the port 8080. Let's check if it works. For that, please open your browser and type localhost 8080. There, you will see the login page. Starting from the top, we have to pick the database engine. In our case, it's PostgreSQL. Next, there is a server field. That's tricky in our case. Normally, you would set there the IP address of your database server, but because we have used Docker and both Postgres and adminer are running in the network managed by Docker, this won't work. We cannot set there a local host. Instead, it has to be a name from the Docker Compose file. In our case, the service of the database is called Postgres. Username, password, and database are as well set in the Docker Compose file. Let's just copy and paste them. When you're ready, click Login. There, you will see your current schema. Now it's empty. So let's create some tables. But for do that, we have to install the TypeORM first. When you go to the official documentation of NestJs, there is a special section about databases. You can copy the installation script from there. However, be cautious. The last package is for MySQLDB. We have to change it to the PG package. PG is a driver for Node and the Postgres. So here we're simply installing the NestJs wrapper for TypeORM, TypeORM itself, and the Postgres driver. Before we start using the TypeORM, we have to import its module inside the root module of our app. Let's open the app module file. We can copy required import from the documentation as well. The TypeORM module comes from nest/TypeORM package. It has a static method called forRoot. This method opens a new connection to the DB. We have to pass to it a configuration object. The first parameter we have to pass is the type of database. In our case, it's just a Postgres type. Next, there is a host setting. We should leave the local host as it is. Our DB is hosted on our local machine, so that's okay. Next, the port is 5432. The username, password, and the name of the DB are consequently equal Postgres, password, and the app. One more time, they are set in the Docker Compose file. Next, there is an array of entities. In TypeORM, the entities are all classes that are mapped by ORM to the actual tables inside the database. We will create some in a minute. Just for now, let's leave it empty. Finally, there are settings about synchronization. Be very cautious with these settings. You may mess a lot in production systems. This setting is useful when we're developing the app. If set to true, it drops and recreates the database each time when we change the schema. In our case, we will leave synchronization on. This way, we won't have to create any migrations. Migrations are so wide topic that I will create separate video about them. Now let's focus on the basics. To make our life easier, I will add another setting. We can turn on login functionality. Okay, one last caveat here. Normally, in real life, we would use the environment's variables to save the credentials. But today, we're just learning the framework, so it's totally fine just to hard code them. Now, let's move to the recipes entity file. In the last tutorial, we saved the recipes into memory. So, the entities were simple TypeScript classes. To make them TypeORM entities, we have to use a few decorators. TypeORM uses decorators a lot, so you have to get used to it. The first one is called just entity. It is decorator for a class. Basically, it tells a framework that based on this class, it should create a table. We can pass a few options to this decorator. The most useful is name option. Databases have different naming conventions than we use in code. For example, we use Pascal case for classes names, while tables are snake case. So, setting name here, we're directly setting the table name in the database. Next, each field of the class have to be annotated with a column decorator. In the options of the column decorator, we can pick the type of the database column. It can be a varchar, integer, or so on. But this type of setting is not mandatory. If possible, TypeORM will infer the type and map TypeScript type to some database substitute. Next, let's think about what every table in a relational database has to have. It's definitely a primary key. Our recipe has a field ID, which will be perfect to be a primary key. There is another decorator for setting the primary key, and it's simply called a primary column. This way, the column will be set as a primary key, but it's not auto-generated. Databases can generate primary keys automatically. If we want to transfer this responsibility to DB system, we can use the primary generated column. We can pick from identity, increment, row ID, or UI ID. Next, we have the ingredients array left. This is classic relation one-to-many. We have one recipe having multiple ingredients. Normally, in database systems, we have three types of relations: one-to-one, one-to-many, and many-to-many. The TypeORM supports all of those relations. To create one-to-many relation, we have to have two entities to connect. Until now, we have only created one entity called recipes. To continue, we have to refactor ingredients as well. So, as previously, let's use the entity decorator and set there the name of the table. Next, the entity has to have a primary key. We can copy the primary generated column from the recipe. This will work very well. Next, the name of the ingredients is a simple string, so it's enough to add a column decorator. Then we have unit enum. This enum has string names associated with. TypeORM won't infer the type of enum by itself, so we have to give him a hint. Inside column decorator, I will set the type to the varchar. This way, when creating the table, TypeORM will create varchar column for the unit. Next, there is a column for a quantity. Let's set its type to the integer. Great, now we have two entities and we can connect them creating relation. Inside the recipe class, we have to annotate the ingredients array with one-to-many decorator. This decorator takes two callbacks as an input. First callback has to return the type of the entity from a second side of a relation. Here we're connecting ingredients, so it will be ingredient type. The second callback is a little bit tricky, so please focus now. In the second callback, we have the object from the second side of the relation, and we have to return the field from this object pointing to the relation. It's not about pointing on the primary key, no. Currently, in the ingredients, we're missing one field. It's not required by our business logic, but it's required by TypeORM. Inside the ingredient, we have to add recipe field. Then, in our decorator, we have to return ingredient.recipe field. I know that it's a little bit confusing, but give me a second to explain it. Normally, in databases, when we have one-to-many relation, the many side have a column containing the foreign key. So it's opposite from what we have in our application code. In code, we have single object containing the multiple nested objects. In fact, the one-to-many decorator is optional. There is one required decorator, but we haven't added it yet. It's many-to-one. Under the recipe field in the ingredients entity, we have to add the decorator many-to-one. Again, firstly we have to return the type of a second side of the relation, and then we have to point to the field of a second object of the relation. Again, for a second, think of the actual database table, not our code. The ingredient have to know about the recipe, because the foreign key of a recipe will be saved inside the ingredient table. Great, now we have a relation set. But before we will move on, I'd like to show you one more thing. The relation decorator has a third parameter. It's optional, but it will help us a lot. Here we can set a cascade flag. If set to true, we can save the recipe and its ingredients using one command. Normally, we would save the ingredients first and then save the recipe. The second useful flag is called eager. It will automatically join our relation if set to true. Without it, we would have to join our tables each time. Cool. Let's move back to the app module. There, we have used the TypeORM for_root method. The entities array is empty so far. So let's add them here, our newly created entities. Without this, TypeORM won't create required tables. Remember to import all of your entities here. Great, we have configs set and entities created. But how to interact with them? How can we query the database and insert some data? TypeORM supports the repository design pattern, so each entity has its own repository. These repositories can be obtained from the database data source. We have to only import them in the module we want to use and inject them in the required classes. Let's open the recipe module. As in each NestJS module, we can import others modules here. So, inside the imports array, let's add TypeORM.forFeature method. ForFeature is used to import needed repositories. In our case, it will be recipe repository. We don't need the ingredients repository because we have used the eager and cascade flags. Now, finally, let's move to the recipes service. Here, we have our in-memory implementation from the last lesson. I will delete all of the implementations, leaving only the headers of the methods. Now, I will inject the repository through the class constructor. So let's create a variable called recipe repository of type repository. Repository is generic class coming from the TypeORM package. Because it's not our class and it comes from TypeORM package, we have to add another decorator. It is called inject repository. It comes from NestJS/TypeORM. We have to pass the entity type to the repository to make it work. Cool. Now we can learn how to implement the CRUD operations. To get all recipes, we will use the find method. It returns a promise containing the recipes array. The last thing is to return its invocation, and that's it. This method also takes some filter attributes, but we don't need them now. We would like to get all of the recipes. Next, to find a single record, we will use the find_one method from the repository. When using find_one, we have to specify the where clause. We will be searching by ID, so here we're simply passing the ID. All of the TypeORM methods are promises. We have to await for the result. This specific method may return our record or undefined. Record with provided ID may just not exist. So here we will check if we have found the recipe. If not, let's throw a not found error. Finally, if the recipe exists, we will return it. To create the recipe, we will use the save method. Here we did a few tricks to make it work, so let's recap. Firstly, the DTO object is almost the same as the entity. The only difference is that the DTO does not have the IDs. Inside the recipe, we have used the primary generated column decorator. So the TypeORM will create the ID for us. Finally, we have used the cascade option in the relation. This allows us for saving the recipe and ingredients in one single query. Next, to update description, we will use the update method from the repository. It takes two arguments. First one is the criteria. In other words, we tell the framework which records we want to update. In our case, it's the recipe having this specific ID. The second parameter is the update. It's the field and the value we would like to set. Finally, to delete the record, we use the delete method from the repository. It takes the delete criteria as an input. In our case, it's ID of the recipe we want to delete. That's it. We have implemented all of the CRUD operations. Now we're ready to check if everything is working as expected. To start development server, please type npm run start:dev. When your app is up and running, you can examine the terminal's logs. When you scroll a little, you will see the SQL queries. The TypeORM created our database in the bootstrap of the app. If you don't believe, let's go to the adminer app. When you refresh the page, you should see two new tables. When you click on the recipe, you will see the ID and the description columns. Next, inside the ingredient table, we have all of the columns set properly. Moreover, there is foreign keys section, and we have the recipe ID there. It looks like we did the correct setup. That's what we want to have. Let's check if we can save some data here. Again, I will use my VS Code extension called Thunder Client, but feel free to use any other tool you want to. Let's start from testing the get endpoint. When we hit the localhost :300/recipe, we should get empty array. Yes, we got 200 and empty array. No errors. So far, so good. Next, let's test the post endpoint. I will save some dummy data here. Yay, 201. When we look to the terminal and we scroll to the bottom, there is a log about SQL insert query. Again, we can check it in the adminer app. When we click on the ingredients, there are two new ingredients added. Moreover, the ID is created and there is an ID of recipe associated with. When we look on the recipe table, the data is also saved correctly. Cool! So now, when we again fetch the recipes, we got the list containing one element. We can grab the ID of the recipe and check endpoint for fetching the specific recipe. Yep, it also works. Instead of array, we have received the single element. Now, let's check the patch endpoint. I will change my description and click Send. Yes, I can see the update log in the console. And when I refetch the recipe, it has description changed. So finally, let's try to delete the record. And small dramatic moment, it won't work. When we hit the send button, there is 500 internal server error. It says we violates the foreign key constraint. It's because we tried to delete the recipe, not deleting the ingredients first. With the TypeORM, it's easy to fix error. Let's open the ingredients class. Inside the many-to-one relation, let's add the onDelete flag. It tells the TypeORM what to do if the recipe is deleted. When we set it to the cascade, each time we delete the recipe, the ingredients will be deleted as well. Let's click Save and try to delete the recipe once again. Yes, this time it works. We have deleted the record. When we use the get endpoint one more time, we will get the not found error. Great! So this way we have learned the basics of the TypeORM. But it's only a tip of the iceberg. We didn't cover the custom repositories, query builders or even subscribers. But fear not, I will cover them all in the upcoming videos. In the next NestJs tutorial, I will show you how to validate the input data, so stay tuned. Meanwhile, thank you for the watching and see you next time.